the paper thing too, darn it. Okay, so, yeah, we'd cut the paper right there, right? And we're gonna keep the part to the right, aren't we? Okay, but the function doesn't go very far. It starts at x is gonna be greater than where the paper's cut, which is -6, but unfortunately, the ant runs out of places to walk on this function, doesn't he? So really, the paper might as well be cut at the other end also, because the function doesn't go any further, right? So there is an upper limit here just because there's an endpoint, right? So what's the other limit going to be? Less than -5, right? Because of that endpoint. Now, what if that endpoint had been solid? What would I have to do? I'd have to include it, wouldn't I? Okay. Make sense? Okay. How about, okay, same idea, right? Almost the same question. We want to know, where is the function positive value? To me, this is easier than increasing, decreasing in a way, because positive value is so obvious. Where's the function positive value?
Above the x-axis.
Yeah, above the x-axis, right? Negative value below. So we're just wanting to know, where is this function above the x-axis? Well, it's pretty clear that this is going from left to right. That's where it starts and that's where it stops for the first loop, right? There it's positive. And then over here again, it goes negative for a while, and then again over there it's positive, right? We just want the x values though, right? So we're going to be my x values that include this loop. X is, how many, and let me ask you this, before we even do this, maybe you should kind of quiz yourself on these as you're going through them. How many endpoints are there going to be to that interval? To this interval? Two. There's a bottom limit and a top limit, right? So I should expect to get to something like that, right? What's the bottom limit? -3. So x is to the right of or greater than -3 and to the left of or less than 0. Okay, comma. And then how about this guy over here? How many endpoints are there on this interval? 1, just a lower limit, right? So we're going to say x is to the right of this limit. To the right of means greater than, right? X is greater than, what is that, 2? So that, comma, that. Make sense? Okay. Average rate of change. Okay, how many people feel like maybe you possibly could have missed this just because it was hard to see exactly where the function, it was so vertical that it was hard to see where it crossed? Did you think? I thought maybe that happened a little bit. So I tweaked this question so that it couldn't be so stretched out. So it's easier to see where it crosses. So the graphics will be a little different next time you get it. So we want to go from x equals -7. So we got to go back to x equals -7. And it's pretty clear on this one that the function is crossing right there. It will always cross at a convenient place, right? It's not going to cross at some fraction or something or some decimal. It's always crossing right at an integer value. So this one is crossing there. At +1, it looks like it's crossing there. So all I've got to do to find the average rate of change is find the slope of that line segment, right? So to go from there over to there, the rate is always just slope, which is rise over 1. What's the rise? 0. What's the run? Well, I guess it's, -7 to 1 is 8, right? If I can count it too. 0 divided by 8 is what? 0. So that's my answer. But it might have been a fraction, right? If it weren't flat, okay? Okay, range. Range. Now, range is that's a red flag word maybe because that means something a little different, right? If we see the word range, if we're writing the range, X's or Y's? Finally, this is the only time that this is Y's, right? Okay, so it wants it using interval notation. So what's interval notation again? That's not the inequalities. This is maybe the easier one. Okay, good. Commas with either brackets or parentheses. I knew what you were saying. All right, so we got a comma, and then we just have to put a value there and a value there. And those are just gonna be the limits, right? Now, this, I know, I can see this, the wheels turn when people do these. Sometimes they get mixed up because they're so used to using x's. But remember, the y-axis is the vertical axis. So whatever goes there has to be the bottom or the lower limit, right? Whatever goes there has to be the upper or the top limit. So you can just kind of turn sideways on this one and say, well, what's the lowest y value if there is one? Is there one? Okay, so this is that asymptote again. What value is y approaching? It's approaching -2, isn't it? So -2 is the bottom limit, isn't it? What value does it approach, or is there a limit? No, so that's just infinite, right? So it goes up infinitely far. That has to be a rounded enclosure, right? Because you can't include infinity, but the question is, what goes there?
Bracket.
Okay, if it's a bracket, it means it includes the point. So this is a tricky one. It's got to be parentheses this time because remember, you never quite get all the way down to the asymptote. Okay, make sense? Okay, real quick, one more like that. What's that one going to be? What's the range of that one going to be using interval notation? So we've got our comma. Is there a lower limit this time? 3. Do we include 3? We do, right? It actually takes a value of 3 at the bottom, right? So that means this time I do put a bracket on the right. Upper limit, is there one? No. So that's the upper limit then, right? There isn't one. Okay, make sense? Okay. And, oh, last one. Last one, and this is another one people miss, but it's so easy. This is one that everybody should get this one right on the test. Let's see, let me just pull up a sample one. This guy. Okay, this is the one where we're just selecting the blue and red graphs that could be inverses. Once again, what is the symmetry that inverses have? Symmetry about, no, not about the horizontal. And let me show you how you can remember this. Here's kind of, because I think I've told you this before, I think if you just memorize stuff, you'll forget it. But if you think about why it is the way it is, you'll never forget it. Think about, let's take one point and let's calculate its inverse. And even that's enough to remind you about the symmetry, right? If I've got, let's say I've got a point whose coordinates are 3, 1. Okay? So there's a point with coordinates 3, 1. What's the inverse of that ordered pair? 1, 3. I just flip x and y, right? So if I flip x and y, I go over 1 and up 3. Well, what line would I reflect the blue point over to get the red point? Yeah, that one, right? The diagonal. It'd be the line y equals x, which is just the diagonal line, right? So that's the line of symmetry. Just pick one test point and you can remind yourself, okay? So then going back to these choices, which one's it going to be? Let's just go through a couple of these. So that doesn't work, does it? It's a wrong symmetry. That's reflected over the x-axis. Wrong symmetry. That's it right there, isn't it? Right? Everybody see? That's the one because I could reflect the blue over the line to get the red or vice versa. Everybody agree? Okay. So that's our answer. Okay. Try. We got it, right? Yeah, we got it. Okay, let's try another one. Not that one, right? Not that one, right? Oh, that's it right there, actually, isn't it? Because that line goes forever, the diagonal line. So that's it. Let's get a point one. That's actually it right there, isn't it? Everybody see? That's reflected over that line. Where's a point one? Maybe I didn't give you a point one. I thought I did. Man, I must not have.
Here's one of like scattered dots.
Yeah, I thought on the test, couldn't a point one show up too?
Yeah.
Oh, there's one, finally, okay. So that one doesn't work, does it? The red line, the red dots, you'd have to, that's the wrong axis of reflection. Wrong axis. Does that work? It works, doesn't it? I could draw the blue dots in wet ink and fold it over the diagonal right there, and I'd get the red ones, wouldn't I? That's it, right? So that's a freebie almost, right? That's pretty easy. Okay, I think you're good. I'll give you a choice. Do you want to go through, I mean, we did this recently. I'll leave it up to you. Do you want to go through a linear regression one? Okay, then I'd say work. You're good. If you want to test, today's your free day on the Unit 2 test. I'll give you a free day today and tomorrow, how about? It's the password for all tests is, I think it's foot. Try foot.
Why do you make weird passwords?
Because I have to change them so I can control when people take the test.
But don't make them weird.
Don't make them, what's wrong? Foot's not weird. Everybody's got feet.
Well, you don't use it as a password.
Wow.
You do now.
At least put like password or something. Not what.
Yeah. Go ahead. Yes.
I forgot how to do all kind of this stuff. And like I kind of stuck on two, like this is just practice test, but I honestly feel like I'm not gonna pass this at all. I don't like, I get everything else, but like the stuff we're doing now, I just don't understand this stuff still. Like no matter how much we go through it.
No, you'll be fine. So what's it have to do to be increasing?
Huh?
It's increasing. What does that mean? If an ant's walking along the function from, in the positive x direction, what's he doing?
It's going up.
Yeah. Does he ever go up on it?
No.
No. So it's in. See what I'm saying?
Oh, because it asks if it's increasing. Okay, we could go over two.
Sure.
Okay, so I was thinking, because range prediction is the one.
That's
where
right. That's right. Except the only problem with this, you're exactly
it's
right.
like,
Yeah, but the only problem is it doesn't include, because he never gets up, that's an asymptote, so it never gets up to that y
so it's
value.
possible infinity.
No, you're right. But you just have the wrong kind, it needs to be parentheses. That's it. Okay, that's it. Okay. So you're gonna get an A on this. I bet you get 100%. Okay, yeah, but now you didn't read the instructions. See, no, inequalities. Okay, to write it doesn't say interval notation, right? It just says inequalities. So now you got to turn that into interval notation. I mean, to inequalities. Right. Mm-hmm. Exactly. Yeah. There you go. Yes. There you go. Okay. Let's see. So rate of change from 1. So at 1, it's right there, right?
Isn't it rise over run?
It is, yeah, to 7. So if I go out to 7, it's right there. So let's look between those points. From that point to the arrow, it's rising by 0. Right? Where were you? Show me, how'd you get? I'm not sure where you were looking because we're going from x equals 1. I know what you did. I know what you did. You did the y values. I think you went from there to there, possibly, or from there to. That's what you did, from there to there. I think. And then you thought it was 2 over 6 and reduced it, probably, right? Yeah. So you're going from x equals 1, which is that point right there, to x equals 7, which is that point right there. So the line segment you would draw would be that line segment. Okay. Because it's horizontal, it would be 0.
So you do the one, you do the x.
Right, because it wants to average rate of change of the function over the interval from x equals 1 to x equals 7.
Is that one?
So how's that one?
Isn't this one?
Yeah, but that's the y value. See, that's x equals 1 right there. Then I have to go up or down until I get to the function. So I got to go up. So there's the function. The function has coordinates x equals 1, y equals 3. But that's when x is 1.
So it would be 3.
And then at 7, it has coordinates 7, 3 also. Right. So the when x is 1, you get coordinates 1, 3, and at 7 you get 7, 3. But think about that in terms of like even the slope formula, right?
because remember we've always kind of probably in Algebra 1 talked about when you calculate the slopes of points, it's y2 minus y1 over x2 minus x1, right? And the first coordinate, when x is 1, y is 3, right? And the other one is when x is 7, y is 3. So that's going to give you 3 minus 3 over 7 minus 1. You see, so that's going to give you 0 over 6, but 0 divided by any number is 0. Yeah. 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 You get that? Here, okay, calculate, while you're here, find the slope between, hey,
Hey,
what's up?
Caitlin Johnson wants me to get her homework for her.
Her home, it's all on Moodle.
On Moodle?
Yeah, it's on, she can just do it it's all online.
Okay.
She knows
awesome.
where to get to it, yeah.
Okay.
You
thank
remember how that works.
Yeah.
So what would the slope be from x equals -2 to x equals 1? So if we're going from the rate of change, average rate of change from -2 to +1.
I think you're still recording.
Oh, I am.